Okay, welcome to Swell Academy. Today we're going with the flow, trying to work on some inequalities and how to graph and solve for solutions. Don't run away from it, don't run against it, just run with it. Here we're looking at a couple x greater than -3, x less than -3. So there is a difference between the greater than and the less than equal to, and I'll show you that in a second. Let's look at this line in red. And we have x is negative greater than -3. So we find where x is -3, and we're going to make a dashed. We're going to make a dashed line. The reason for that is because we are not including -3. It's greater than -3. It's not equal to -3. And the idea about graphing an x as a vertical line is each and every point on this line has an x coordinate of -3. So that's the idea there. Basically, each and every one of these coordinates is a -3. So if we were to plot all those points, we'd end up with a vertical line. Same with x is less than -1. And here we're going to use a solid line. We're going to use a solid line. And the reason for that is because we want to actually include the 1. And then when you're going to shade, what I like to do is just get a direction. So let's look at this, let's say yellow. We're going to do greater than 3 is generally to the right. These are values greater than and to the right of this line. And if we look at another color, let's look at blue here, and we're looking at less than -1, we would have shaded to the left. So the area and the solutions to these two equations fall somewhere in between these two lines in this shaded area, and that's how you visually show what our solutions are. Now it gets to be a little different when we have our y values. Let's look at a y is, let's say, greater than or equal to -3, and we'll look at a y is less than, we won't use the equal sign or less than equal sign here, less than 4. Again, I go where y, because this is my y line, where y is -3, and I'm going to draw a solid line because we have a greater than equal to. And then I'm going to go to where y is 4 here, and I'm going to use a solid line because we do not have an equal to symbol here. And then the shading goes along with it. So greater than -3 would be above this line, here. And then y less than 4 would be below this line. And this is kind of where we come up with this shaded area here. And this is what you'll use for your solutions. Let's look at a couple other problems. I have one here that actually has an x and a y, which I think is good. Notice that there's no equal, less than, equal to, greater. So these are all going to be dashed lines. We got x at 1. So I go where x is 1 and draw a vertical line. The x's generally x's are vertical, y lines are horizontal. That's just a good little key to have as you go through this. And then we have another dashed line at where y is equal to 4. And then this is a little different because you have a vertical and a horizontal line. With the x, you're going to shade everything less than 1. So we're going to make some bigger shades this time because we're going to look for some. Now, since x is a vertical line, I'm going to use horizontal lines to shade, and I'll do the same with the y. Since y is a horizontal line, I'm going to use, this is my x shading. We'll use green for my y shading. I'm going to use vertical lines, so everything less than 4. And this is the shaded area we have in here. Let's just use like maybe a highlighted color in yellow. And this is our area that's shaded here. And the reason we're picking this area is because this is the area where the lines intersect. This is the the section of this graph where the solutions intersect themselves. We were dashed from here on another one here. This one's a little different because you're not just given the x and y line. There's actually some slope intercept involved in this. So for instance, with this line here, you have a y-intercept of -7. So I go to the -7 here. And then I have a slope, or m, of 3/1. So I go up 3/1, up 3/1. And that's just the general idea here. And we make our line. Not a bad line there. And then in green, we'll look at this. We have a y-intercept of 1 and a slope of -1/8. So I'll go where y is equal to 1. And then I'll go down 1, 1, 2, 3, over 8. I also kind of graph this by going back 8, up 1. Just kind of like an inverse of that. And then we wanted greater than the 3x minus 7. So the idea here is this is tougher. Like, do we shade to the right? Do we shade? A lot of this comes on the idea that we're looking to shade up. Up if it's greater than, with these cases, down if it's less than. So we want values to be going up. We want to shade in an upward fashion. So down when it's less than. So we'll look at this in red. We'll shade this one. This is basically, I don't want to use green here. Let's use the yellow. I want to shade up. Yeah, you could shade to the right, but generally we want the values to go up because we're talking about y. Since we're talking about y, these values of y are greater than, we want to shade up and down because we're using y as our basis. Y is the vertical line. The y-axis goes up and down. So if you're saying greater than, you should be shading up for the y. And if it says also y is greater than, for greater than equal to -1/8, we'll do the same. We're shading up. And you could see already you have this area that overlaps itself. Let's look at it in purple, and we'll highlight this area that is intersecting. And this is your shaded graph, which gives a solution of this system of equalities by graphing. Let's look at another, make sure everything's, yeah, we have another dashed line here. The y is greater than. This we would have wanted to make dashed. Go back and look at some of my mistakes here. It's solid, so we were basically focusing on the graphing and the shading. We forgot about the nipple here. This one's good to show because we're working with your x and y intercepts. You're working with 0. So let's look at this in green. Basically, what we're going to do is, okay, so we're going to set y equal to 0 and solve for x for the green. So we have -3x plus 2 times the 0. And I'm just say equal to 12 because I'm trying to find my intercepts. And -3x is equal to 12. X equal to -4. So I'll plot the -4. I'll do the same for y. I'll set x equal to 0. So basically I end up with 2y equal to 12. And my y is equal to 6 here, so I'll plot my 6, and then I have my line by connecting these 2 points. And again, we're looking at greater than. Y is everything. -3x plus 2y is greater than 12. And again, we're trying to shade in an upward or downward fashion based on our y-axis. Now, one thing you could do to help is, we'll test it. Let's say you want, maybe, do I need to shade to the right or left of this, up or down? Let's just pick a point here, 0, 4, an easy point to work with. And okay, is that going to be a solution? -3 times 0 plus 2 times 4 is greater than 12. Is 8 greater than 12? It is not. So we know that this would not be a solution, so we'll shade to the other side of it. This is a good little trick in case you're not sure where to shade. And then let's look at 2 2x equal to 20, x is equal to 10, 5y is equal to 20. And again, I'm doing this by setting x or y equals 0. I'm trying to eliminate some steps here. And then you have x is equal to 10, y is equal to 4. Here's your line. In this case, we're talking less than, so we're going to shade down. Our overlapping area is here. And this is our set of solutions we've created by graphing. Back one, we have to take a look at this here. That'd be the same thing. Our lines would in fact be dashed. So let's use a little eraser and make these dashed lines here. Yeah, these would be dashed. Let's just check out dashed. Here's another example here. And this is something you could just do with the previous question, having that understanding. But what we want to do is kind of get the x and y on the same side with this. This is the trick here with this piece here. So really you have, if we're going to, let's bring the negative 108 to the other side. So we have negative 108 is less than 36y plus 9x. And then what I like to do to get the x's and y on the other side is I'll say 36y plus 9x is greater than negative 108. Just recognize what I did there. I brought the 108 to the other side so I can use x-intercepts. And because I visually like the y and x on the same side, what I did was just basically switch it, but I also switched the sign from less than to greater than. And then I could go ahead and solve for my x-intercepts by setting, the x and y equal to 0, 36, y is equal to 108. I have my y equal to 3. Or actually, it's negative 108, so we have negative 3 here. So go to the negative 3. Then I have 9x is equal to negative 108, which would make x negative 12. That's a big number here. It's a little off the screen here, so maybe it's over here somewhere. And then same thing with x and y on our second equation here. Doing negative 9x is equal to negative 90. And then we also have the 10y is equal to negative 90. So x is equal to 9. And y is equal to, actually this should be 10. And y should equal 9. So my y is 9 here. My x is 10. I'm going to graph this line here. Now it is solid because we have the greater than equal to, and we might have to go back and look at the other one. So I'm shading here. And then for our our red line, that's also greater than. So I like this one because this kind of has these lines and one is underneath the other, so the solution is above. And actually our line should be dashed here, and we don't want to forget that. I kind of went ahead and just started making lines, but this is a dashed line because this is just a less than symbol. And so don't forget about your dashed line. You can learn from my mistakes here. Hope this is helpful. There's a lot of little pieces to keep track of. Try to match up your problem with what you have. Take it through the steps. And if you make mistakes like I do, just quickly learn from them and keep working at it.